All right, let's dive right into this explainer. Look, if you've spent any time messing around with large language models in a chat interface, you already know it kind of feels like pure magic, right? You type a casual prompt, maybe tweak a word or two, and bam, you get this incredibly human-like answer. But today, we're leaving that chat window completely behind. We're looking directly at Chapter 6 of the Developer's Guide to AI, which is all about taking that prompt engineering and embedding it straight into your actual code. We're shifting our mindset. We're moving away from those casual AI chats and stepping onto the factory floor, the rigorous, highly structured, and, let's be honest, sometimes completely unforgiving world of production-grade software engineering. Because out there, you need to make that magic reliable, scalable, and totally crash-proof. So, the crucial point we're tackling today really just boils down to this single concept. Writing a great prompt is only half the battle. Think about it. The very second you drop that beautifully crafted magical prompt into a live codebase, the rules of the game completely change. You aren't just trying to get a cool response anymore. They're orchestrating a whole system. You're entering an arena where you suddenly have to deal with application state, wild user inputs that you literally cannot predict, and super strict formatting requirements that your downstream code desperately relies on. Okay, here's our blueprint for today. We're going to cover 1. Playground to production, 2. Libraries and model settings, 3. Mastering prompt templates, 4. Structuring messages and roles, 5. Production and request retries, and finally, 6. Implementing robust guardrails. Let's get into it.
Section 1. Playground to production.
Taking a prompt from a comfy web browser and deploying it onto a live user-facing server, yeah, that introduces a pretty harsh reality check. In a chat interface, if a model gives you a weird or poorly formatted answer, it's no big deal, right? You just rewrite your prompt, hit enter, and try again. But out in the wild, in a production environment, speed, cost, and reliability are literally what dictate your success. First up, let's talk about latency. In production, every single millisecond counts. When a user clicks a button on your app, they expect an immediate response. But LLMs, they take time to process and generate text. You'll often hear this called time to first token and total generation time. You've got to design your systems to handle this delay, maybe by streaming responses or using background workers, because trust me, a user staring at a loading spinner is just going to bounce. Second, tokens cost real money. In a playground, you might just paste in a massive document without a second thought. But in code, every back and forth, every context window you fill is driving up your AWS or API bill. You suddenly have to be incredibly efficient with how much context you're actually providing. And finally, the absolute most chaotic element: unpredictable users. Let's face it, users do not read the documentation. They will throw completely random, bizarre, or even maliciously crafted inputs at your application. They're going to try prompt injections. Your system has to handle all these edge cases flawlessly, without you sitting there manually intervening. Basically, your prompts have to be bulletproof.
Moving on to Section 2, Libraries and Model Settings.
So once you're actually in the code, your very first major architectural decision is choosing your toolkit. You can't just blindly send raw text over HTTP without some kind of structure. You generally face a choice here. Do you build with a lean, lightweight SDK wrapper, like the official Python or Node packages provided directly by the model creators? Or do you utilize a high-level, opinionated framework? Both absolutely have distinct places in modern AI engineering. Lightweight SDK wrappers are fantastic when you need absolute control and minimal overhead. They give you exactly what you need to hit the API, handle your authentication, and get the response back, leaving all the actual application logic entirely up to you. This is perfect if you're building a highly performant microservice and want to keep dependencies to an absolute minimum. On the flip side, high-level opinionated frameworks bring a massive amount of built-in tooling to the table. Say you're building some complex orchestration, like a multi-agent system, or a deep retrieval augmented generation pipeline where you're parsing PDFs, chunking text, embedding it, storing it in a vector database, and then running a chain of prompts. An opinionated framework is going to save you thousands of lines of boilerplate code. The trade-off, though? These frameworks can sometimes be pretty rigid, which makes it a lot harder to debug when things inevitably go wrong under the hood. The key takeaway here is making a really intentional decision based on whether your specific project requires that granular control, or if you just need rapid development for complex workflows. Beyond just the libraries, moving to code means you are taking direct control over the model's fundamental behavior, using specific configuration parameters. You aren't just sending instructions anymore. You're actively tuning the engine. Let's look at how these work mechanically. First up is temperature, which controls the randomness of the response. If you set that temperature to a value close to 0, the model becomes highly deterministic. It's basically going to consistently choose the most probable next word. This is exactly what you want if you're building a factual data extractor, a text summarizer, or a code generator where precision is everything. But if you turn that temperature up towards 1.0 or even beyond, the model starts taking risks. You get more creative and varied outputs, perfect for, say, a brainstorming tool or a creative writing assistant. Then we have top P, which is also known as nucleus sampling. Instead of tweaking the randomness, top P controls the actual pool of words the model can choose from, based on their cumulative probability mass. So if you set top P to 0.1, the model is only going to consider the very top 10% of likely next words. Now, a quick pro tip. Developers will usually adjust either temperature or top P, but rarely both at the same time, just to really dial in that exact behavior they need. And finally, max tokens. This is your ultimate safety valve. It caps the total length of the response, which directly controls your costs and prevents some runaway generation loop from completely freezing your application and draining your entire budget. You need to adjust these knobs with absolute intent for every single feature you built.
All right, Section 3, Mastering Prompt Templates.
As your prompts grow in length and complexity, hard coding them directly into your application functions quickly becomes a total maintenance nightmare. Enter the prompt template. A prompt template is a foundational structure that captures all the parts of your prompt that stay exactly the same: the core instructions, the rules, the tone, while using dynamic placeholders for the parts that will change based on user input. Why do we do this? Simple. So our code base doesn't become a brittle mess. When you're dealing with raw text strings in code, you're constantly battling with escape characters, unexpected quotation marks, and random line breaks. And those little things, they can silently break your code or completely malform the prompt payload before it even reaches the LLM. Templates gracefully abstract all of that formatting away.
Just look at this. Instead of messy string concatenation, where you're manually sticking strings and variables together with endless plus signs, imagine using a clean, isolated template instead. String concatenation is incredibly hard to read, it's a nightmare to maintain, and it is highly prone to bugs. I mean, if a user inputs a string that happens to contain an unescaped character, your entire API request can just fail on the spot. But by utilizing a templating system, something like Jinja 2 in Python or handlebars in JavaScript, you create a pristine document using double curly brackets for your placeholders. Then your application logic simply calls a render method and passes in a dictionary of variables, like the user-specific question or the text of an article they want summarized. The templating engine takes care of safely injecting that dynamic data into your static prompt structure. This clean separation of concerns is a game changer. It means your prompt engineers can go in and tweak the instructions in a dedicated template file without ever having to touch or risk breaking the core application logic. Plus, it enables massive reuse across different application flows. It really brings a level of much-needed software engineering discipline to how we handle AI inputs.
But building a truly enterprise-grade template requires upgrading your basic instructions in 3 highly specific ways. First, you absolutely must add a persona. By instructing the AI to act as, say, a senior database administrator or a friendly customer support representative, you are effectively anchoring the model's massive vector space down to a specific domain. It drastically narrows down the types of vocabulary and reasoning paths it uses, which leads to much more consistent output. Second, you've got to use delimiters. When you pass dynamic data into a template, the model needs to know exactly where your instructions end and the raw user data begins. By wrapping that user data in XML-style tags, like an opening and closing article tag, you create clear boundaries. This helps the model parse the information correctly, and honestly, it's a crucial defense against prompt injection attacks, where a user might try to sneak in malicious instructions disguised as data. Third, and actually, this might be the most massively important one, add uncertainty handling. Look, language models are fundamentally designed to generate text. They want to answer you. If they don't know the answer, they'll often just hallucinate and present a completely fabricated answer with absolute confidence. In code, a hallucination is incredibly dangerous because your downstream functions might just execute based on that completely false data. You have to explicitly instruct the LLM to give a standardized response, something like "I don't know," whenever it lacks the context to answer accurately.
Okay, Section 4, Structuring Messages and Roles.
So now that we have these pristine, dynamic templates, we need to look at how the code actually formats the conversation. In modern AI development, you don't just send over a single massive block of text. API payloads actually expect an array of structured message objects, which are separated into distinct roles. Think of the AI itself as the assistant persona.
The overarching instructions, the core rules of engagement, the templates we just talked about, all your guardrails, those are passed in utilizing the system role. The model gives an incredible amount of weight to that system prompt. It acts as the unbreakable foundation for the entire session. Then, the actual queries, the real-time inputs coming from your human users, those are sent using the user role. The model processes that user query through the lens of the system prompt and then responds as the assistant. By structuring your payloads exactly like this, you ensure a really clear hierarchy of commands. It keeps your application's fundamental rules securely separated from the ephemeral, totally unpredictable queries of your users.
Next up, Section 5, Production and Request Retries.
Transitioning over to the factory floor means facing a pretty difficult software engineering truth. It is not a matter of if an API request will fail in the wild, but when. When you rely on third-party language models, you are introducing a massive external dependency into your stack. You are definitely going to face temporary network timeouts, 502 bad gateway errors, and strict rate limits. But you know what's even trickier than network blips? Schema validation failures. You might send over a perfect prompt asking for a strict, nicely formatted JSON object containing a simple Boolean true or false. But occasionally, the model will just reply with a sentence like, yes, the condition is true. Now, to a human, that makes perfect sense, but you're parsing code that's sitting there waiting for a Boolean, that triggers a catastrophic crash.
Thankfully, modern libraries provide a really robust solution for this right out of the box: request retries. Both those lightweight wrappers and the high-level frameworks we discussed earlier have built-in mechanisms to automatically catch these failures and reattempt the prompt request. They typically use a concept called exponential backoff. The system waits a short time, tries again, and if it fails again, it waits a slightly longer time, often throwing in a bit of random delay called jitter, just so it doesn't overwhelm the server. This ensures that a simple network timeout or a momentary hallucination where the model just forgot to output JSON doesn't crash your user's entire experience. Your code simply catches the parsing error, recognizes that the schema was violated, and seamlessly asks the model to try generating it again entirely behind the scenes.
And finally, Section 6, Implementing Robust Guardrails.
Listen, if you take away only one core concept from this explainer today, please let it be this triad of best practices for writing production guardrails. To ensure your AI features do not sacrifice consistency, compliance, or security, you absolutely must implement these 3 golden rules directly into your prompt architecture. Rule number 1, order deeply matters. Literally, where you place your instructions in the prompt completely changes how much attention the model pays to them. This relates to a well-documented phenomenon often called the lost in the middle effect. Because of how the attention mechanisms in transformer models actually work, LMMs tend to heavily weigh the instructions at the very beginning of a long prompt sequence and the instructions at the very end. The content in the middle, it can often just blur together or be ignored entirely. Therefore, you must always front-load and tail-load your critical guardrails around your dynamic text. You set the core constraints at the top of the template, you inject that massive, unpredictable block of user data right in the middle, and then you reiterate your most critical rules at the absolute end, right before the model begins to generate. Rule number 2, redundancy beats cleverness. Look, as software engineers, we are practically hardwired from day one to keep our code dry. Don't repeat yourself, right? We write modular functions specifically to avoid repetition. But when you are engineering prompts for an LLM, you must deliberately break that rule. You absolutely should repeat yourself. You must reassert critical constraints after every single mutable section of your template. Think about it. If it is absolutely critical that the model only responds in French, and you're passing in 3 different blocks of English context, you should explicitly state, respond only in French, before the first block, between the blocks, and again after the final block. Redundancy is your ultimate safety net against a language model wandering off track inside a massive context window. And rule number 3, expanding on what we touched on earlier, just because its implementation is so incredibly vital, ensure uncertainty handling by providing an explicit failure phrase. You have to instruct the model, if you cannot find the answer in the provided text, reply exactly with the string, "I am sorry, I cannot help with that." Now, why do we do this? Because it perfectly bridges the gap between natural language and traditional code. By giving the model a highly predictable, exact failure string, your regular Python or Node backend code can simply run a basic string matching if statement. When your code sees that exact phrase, it knows the AI failed safely and it can trigger a graceful fallback, like routing the user over to a human support agent instead of letting a wild hallucination leak out into production. So as you head back to your IDE today, I want you to ask yourself this final question. Are your prompts currently being treated like basic disposable text strings, Or are they being treated with the exact same rigorous, structured discipline as the rest of your code? By migrating to structured templates, intentionally configuring your model settings, utilizing explicit API roles, gracefully handling request retries, and baking in those redundant, carefully ordered guardrails, you can finally step out of the playground. You can start building intelligent AI features that will actually survive, scale, and thrive out in the real world.